Okay, for this question, there's a two diagram given. On the first diagram, an aluminum plate is dropped within a north south pole magnet, whereas on the second diagram here, a plastic plate is dropped between a north and south pole here. And the question states that the movement of the aluminum plate slows down as it moves through the magnetic field of north and south, whereas the plastic plate accelerate with the gravity acceleration. And the question asks you to explain why is this so. Okay, looking at the first diagram on the aluminum plate, an aluminum plate is dropped between a magnetic field. So when the aluminum plate is passing through the magnetic field is indeed going to act from the north to south pole. This is the direction of the magnetic field, labeled with a green arrow. And the blue arrow here is exactly showing you the movement of the plate. So as the aluminum plate falls within the magnetic field, there's a change in magnetic field occurs. So point number one, take note, point number one, as the aluminum plate drops, there's a change in magnetic field happens. Next point, according to Faraday law, according to Faraday law, EMF will be induced in the aluminum plate due to the change of the magnetic field. So point number two, EMF induced due to change in the magnetic field. Point number three, this exactly will form an eddy current in the plate. It forms an eddy current on the plate. And remember, eddy current has its own magnetic field. Point number four, eddy current will have its own magnetic field, and this magnetic field will act in a such direction opposing the change that causing it. So again, let's repeat the whole answer. When the aluminum plate is dropped between the magnetic field, there's a change in magnetic field occurs. Point number two, according to Faraday law, EMF is induced due to the change in the magnetic field. Okay, this exactly forms an eddy current in the plate. Okay, the current forms in aluminum plate has its own magnetic field, and this magnetic field will descend or will slow down the motion of the plate as it acts on the opposite direction. The answer that was given to you have been as what you see here, where the first one is exactly stating about the eddy current, and the current establishes that the magnetic field formed by the eddy current oppose the change in flux, and this will exactly leads to a repulsion or slows down the movement of the aluminum plate. Whereas in a plastic plate, there's no change of magnetic field will occur because it doesn't conduct any electricity here. Therefore, the plastic plate will drop with a gravity acceleration. The next question here has given you a diagram of a magnet which is being moved away from a coil of a solenoid, and the solenoid is indeed connected to light bulb here. So the diagram shows the magnetic being pulled away from a solenoid that is connected to a light bulb. Indicate the direction of induced current in the solenoid. Draw an arrow on the diagram and label it current. So before even we do that, let's look one by one step here. What is exactly happening here? As the magnet is moved away, remember here, whereas the magnet is moved away from the solenoid, as the magnet is moved away from the solenoid here, what will happen? The number of magnetic flux that cuts the coil is indeed decreases. Point number one, magnetic field that cuts the solenoid decreases. Point number one here, solenoid decreases. That's the first point that you got to take note here. Second one, let's what happened next. Now, since there's a change in magnetic flux occurs, change of magnetic flux occur here. Point number two, change in magnetic flux occurs, and therefore, due to the change in magnetic flux, EMF will be induced in the solenoid. Okay, and the EMF induced in a solenoid will act in a such direction to oppose that changes that causing it. So in this case, since the magnetic field that cuts the solenoid decreases, the EMF induced will have its own magnetic field, and this magnetic field will travel in a such direction to oppose the change. So since the magnetic field is the magnet here, the magnet given is moving towards left, therefore the coil that is produced here will have a magnetic field, and this one will act as a north direction. The left hand of the solenoid will be acting as a north pole, whereas the right one will act as a south pole. Why is it so again? The magnet is moved away from the coil. When the magnet is moving away from the coil, number of magnetic flux that cuts the coil decreases. Due to the change in the magnetic field, EMF is induced in the coil. The EMF induced in the coil will direct in a such direction opposing the change that causing it. Since the magnet is moving away, the solenoid here will have a magnetic field as though opposing it or to attract back the magnet which is moving away. So the left hand side of the solenoid acts as a north. By using your right hand grip rule pointing towards the north hand side direction, you'll be able to find the direction of current from the rest of the fingers, which is going to direct upwards, as what you can see here. Okay, next one. Briefly explain why a current flows at this instant. So the exact definition. Firstly, as the magnet is moved away from the coil, there's a change in magnetic flux occurs. According to Faraday's law, EMF is induced due to the change in magnetic flux. Current induced in the coil has its own magnetic flux, okay, or magnetic field, which oppose the change that causing it. Therefore, a current flows as shown in the diagram.